Okay, we're going to talk about the fundamental counting principle and permutations. And your essential question is, how can you determine the number of ways an event can occur? And I'm going to show you a couple ways to do this. All right, so let's think about a scenario here. You eat at the same small deli every day for lunch. The deli offers 4 types of meat: ham, turkey, roast beef, and pastrami, and 3 types of bread: white, wheat, and rye. How many choices do you have for a meat sandwich? Right? So how many different sandwiches can you have before you have to eat the same sandwich again? All right, well, one way that you may have learned in the past is to draw a diagram to represent this. So I can say, well, I have different choices of meat. I can have ham. I can have turkey. I can have roast beef, I'll abbreviate RB. And I can have pastrami. Okay, now for each of those types of meat, I can have 3 different types of bread. So I could do a ham with white, a ham with wheat, and a ham with rye. So just with ham sandwiches, I have 3 choices, or I have 3 different options. And the same is true with turkey. So I could do white, I could do wheat, or I could do rye. The same will be true with roast beef. The same will be true with pastrami. So just with the 2 that I've already diagrammed out, well, it looks like I have a total of 6 choices, right? A ham with white, ham with wheat, ham with rye. Turkey with white, turkey with wheat, turkey with rye. I could do roast beef with white, wheat, rye. Pastrami, right? So hopefully you're seeing that you have 4 different groups of 3 sandwiches, of 3 different choices of sandwiches. So altogether, you would have a total of 12 choices. Or again, those 4 different groups of 3 different sandwiches, right? So that gives you that total of 12 choices. So that's one way. You've probably done this in the past, okay? And this leads us right into the fundamental counting principle, which is down here. So I don't have my highlighter with me, but that's okay. I'll use a purple pen. So if you have 2 events, if one event can occur in m ways and another event can occur in n ways, then the number of events that both events can occur is m times n, which is what we just did. And that will be true. That will remain true. And there's an example here. But that will remain true also for 3 or more events. So the same thing, if you have 3 events happening, the ways that all 3 events can occur, let's just multiply those 3 events together. Okay, so that's pretty simple, pretty straightforward. Okay, so let's move on to the next page. Put it into action. So now you own a restaurant that offers a dinner special, including an entree, a salad, a drink, and a dessert. You offer 8 different entrees, 2 different salads, 12 different drinks, and 6 different desserts. So how many choices for different dinners consisting of 1 salad, 1 entree, 1 drink, and 1 dessert do your customers have? Well, again, they've got a choice of, 8 entrees, 2 salads, 12 drinks, and 6 desserts. So if you were to put this in your calculator, you would get a total of 1,152 choices, which might be an important business decision. Do you want to give people a bunch of choices, or do you just want to let them have a few choices? Right? You're going to have to make these many different combinations, but people do like a lot of choices. All right, let's try another one. This one gets a little bit more tricky. So when we think of new telephone codes are added when areas run out of available telephone numbers. Okay, this actually happened in the town that I grew up in. We used to have an 805 area code, and at one point it just got too crowded, and so it became a 661 area code, which was really interesting. So new telephone codes are added when areas run out of available telephone numbers. Telephone companies need to know how many phone numbers are possible for each area code so they can plan for when a new area code will be needed. How many 7-digit phone numbers are possible if the first digit cannot be 0 or 1? So this kind of adds a little trick, right? It's not going to be as straightforward as this. This was, my first choice I got 8. My second choice I got 2. Okay, 12, and so on. Well, my first choice here cannot include 0 or 1. So I've got 9 digits that I've got up to 9, the number 9 that I can use. I need to get rid of the first 2 digits. So that's a total of 10 digits, right? 0 through 9. So that means that for my first choice, I've got 8 digits to choose from. Well, my second choice, because the rest of the digits, the rest of the 7 digits can be any of the 10 digits. There can be a 0, there can be a 1. So the second number can have 10 potential possibilities. The third number, 10 potential possibilities. The fourth number, 10 potential possibilities. Fifth number, sixth number, seventh number. So I've got an 8 here times, really, this is 1, 2, 3, 4, 5, 6 zeros. Okay, so really it's going to be 8 followed by 6 zeros. So I've got 8 million different phone numbers. Pretty interesting stuff, I think. Pretty useful. Okay, so let's talk about what a permutation is, and it's in your book if you want to read up more about it. But a permutation is basically an ordering of n objects. We'll use n to represent whatever that number happens to be. So for example, let's say I have 3 objects. We'll call those objects A, B, and C. What are the different ways that I can order A, B, and C? Well, I can order it A, B, C or A, C, B. Oops. I could start with B instead. I could do B, A, C or B, C, A. I could start with C instead. I could do C, A, B or C, B, A. I think I've done all possible orderings of these 3 objects. So I have a total of 6 permutations. Which really is the same as saying, well, this is the same thing as 3 times 2 times 1. Okay, we'll come back and explore that in a minute. But really, 6 is the same as 3 times 2 times 1. I had 3 objects that I started with. I ended up with 6 permutations or 6 different orderings of these objects, which is the same thing as taking that number 3 and multiplying it by every consecutive integer after it, right? Consecutive integer meaning the next whole number that's less than it. Okay, so let's give a little definition here of what that looks like. So the number of permutations of n distinct, so they have to be distinct. They can't be exactly the same. Objects is n factorial. So this little symbol right here, we call that a factorial. It's not an exclamation mark. It's a factorial. And what that means is that you take that number and then you multiply it by every consecutive integer that is less. So n, if n is your original integer, then your next consecutive decreasing integer is going to be 1 less than it. And the next one after that is going to be 2 less than your original number. And the one after that is going to be, 3 less. And on and on and on until you get down to the actual numbers like 3 times 2 times 1. Okay, so another way that I could have written this 3 times 2 times 1 is really 3 factorial. Okay, so that's the number of permutations, or the factorial. Okay, now what if I take a certain amount of objects from a group of n distinct objects? So this was one of our important things. But another really important thing is that what if I choose to take only a certain amount of those distinct objects at a time? So the number of permutations of R objects taken from a group of n distinct objects is, and it looks like this, it's a sub n, so it's a small n, a large p, and a small r. So these are like subscripts. And if it's confusing for you, you should look in the book. Okay? And the way that we write this, or the way that we represent it, it's equal to n factorial, so the number of distinct objects, over, again, the number of those distinct objects minus the number of R objects that's taken from that group, factorial. Okay, so we've got two things here that we're going to work with. Okay, and maybe you need to highlight these, but one of them is just dealing with the factorial that will give you the number of permutations of those n distinct objects, the different ways that they can be ordered. Okay, and then the second one is when I actually, from those n objects, I take only a few of those. I don't take all of them. Okay, I don't care about all of them. All right, so let's do some examples with those. So example 3. You have 12 skiers are competing in the final round of the Olympic freestyle skiing aerial competition. In how many different ways can the skiers finish the competition? Assume there are no ties. Okay, so in how many different ways can these 12 skiers be ordered is what it's asking. So for A, it's quite simple. All you do is 12 factorial. Now this would be the same thing as 12 times 11 times 10 times, and so on. Okay, do we really want to do all that? I hope you were saying to yourself, no. Okay, so let me show you how to do this on the calculator. So get your calculator out. Oh, don't look. Okay, so we want 12 factorial. So you're going to do 12, and then you're going to hit the math key, and you're going to want to go all the way over to probability, and you can see number 4, there's a factorial. You can also see number 2. Doesn't that look like what we just wrote? N permutation R. Okay, so this is, you want math probability on your calculator. Okay, so let's go ahead and hit 4. Oops, I gotta use my arrows. It gives me the factorial symbol. I press enter, and I get an answer. Whoa, that's a large answer. Okay, so I get about 47 million, 47.9 million. Okay, now let's do B. So let me move this out of the way so I can read it. And how many different ways can 3 of the skiers finish first, second, and third to win the gold, silver, and bronze medal? So this is where you have, 12 objects, but you really only care about 3 of them. Okay, and we don't care about the order that they're coming, right? Anybody can finish first, anybody can finish second, anybody can finish third. We just want to know how many different ways that can be ordered. Okay, so that's where we're going to say, all right, I've got 12 things, and I just want to choose 4 of them. Oops, not 4, sorry. 3. I just said 3. I just wrote 4. Okay, so there's a couple ways we can do this. One is using our calculator. Another way that I want to show you now, and then I'll do it a different way later. You can say, okay, this is the same thing as 12 factorial over 12 minus 3 quantity factorial. So this is really 12 factorial over 9 factorial. Now watch how we can reduce this. There's a way to simplify this. Okay, so I can say, well, this is really going to be then 12 times 11 times 10 times 9 factorial, right? That would take care of everything else over 9 factorial. Well, what's the common factor in numerator and denominator? The 9 factorials, those reduce. And I'm really just left with 12 times 11 times 10. So 120 times 11 gives me 1,320. So that's one way of doing it. The other way that we can do it is we can go onto our calculator and we can go, actually you'd have to type 12 first. So this first 12 you would have to type in your calculator. Then you go to math, you go to probability, you go to number 2, and then you type in the second part of it, which is 3. Press enter. I get the exact same number. So 2 ways of doing this. It's good to be able to simplify these things, but it's also good to be able to use your calculator quickly. All right, let's try example 4. So there are 9 baseball players on a team. In how many ways can you choose the batting order for all 9 players? Well, that's just, we got 9 things. How many different ways can we order them? So that's going to be 9 factorial. Again, you use your calculator. You just go to math. Oh, no, you got to type 9 in first. You go 9, math, go over to probability. You can either type in 4 or you can hit down to 4 and press enter. 362,880. Now for B, I need to choose a pitcher, a catcher, and a shortstop from the 9 players. So this is one of those situations where I don't care about the ordering of all of the players. I just care about the ordering of picking 3 of them. So I've got 9 total. I want to know the permutation of picking 3. Okay, so this time I'm just going to go to my calculator and I'm going to do 9 permutation 3. So I'm going to do 9. Then I go to math. I go to probability. And I'm going to choose, oops, what just happened? I messed something up. Let's try that again. So, you guys are probably ahead of me now. I'm not sure what I did. Probability. And then I'm going to go down and choose number 2. And I'm choosing 3. 504. Not too challenging, right? I guess it's going to be really important then that you write yourself a note about how you use your calculator. So both permutation and the NPR are found by going to math and then probability. Okay? Okay, so far we've only used distinct objects. We haven't had anything repeating. Now what happens if some of the objects are repeating? So, if some objects are repeated, then some of the permutations are not distinguishable. Let me give you an example of that. I'm going to use 3 different colors. So I'm going to, let's see, let's get these all going. So let's use 3 letters. Mom. 2 of those letters are repeated, right? The M's are repeated. So I could write them in a different order. But if I didn't have color, that wouldn't look like they're in a different order at all. Okay, and the same thing goes with, I can write them in, I could do O, M, M, or I could do O, M, M. Or I could do M, M, oops, O, or I could do M, M, O. Again, if these weren't in different colors, you wouldn't be able to distinguish them. So really, only 3 of them are distinguishable. So without color, only 3 are distinguishable. So really, this would be the same thing as saying 3 factorial divided out the 2 repeating things, right? So the 2 M's are repeating. Well, this is really the same as 3 times 2 factorial over 2 factorial. I'll reduce those 2's, 2 factorials I mean, and get a 3. So really there's only 3 distinguishable orderings. Okay? So that takes us to the next page where there's an actual formula for that. There's a way of doing that. So if you can find the number of distinguishable permutations of n objects where an object is repeated Q1 times and another is repeated Q2 times and so on by basically taking that number of objects, factorial, and then dividing out those things that are being repeated. So let's do that in our last example here. Example 5. I have summer. Summer has 2 letters that are being repeated, okay, or 1 letter that's being repeated twice, okay? So altogether, let's see, there's 2, 4, 6. So that means I'm going to take, for A, I'm going to take my 6 factorial, but I need to divide out the fact that I have something being repeated 2 times. So I'll divide by that 2 factorial. Okay, and you can do this in the calculator. You can simplify it first. It's up to you. Two factorials go away. I've really got 30 times 12, which is 360 possible combinations. Now B is different because not only do I have 1 set of letters repeating, I actually have both A's and L's. So I have 2 sets of letters that are repeating. Let's see, so I've got 2, 4, 6, 8, 9. So I've got a total of 9 letters, but I need to divide out everything that's repeating. So 2 factorial for the 2 A's, and then another 2 factorial for the 2 L's. Now it's going to be, you have to be really careful here. These do not just multiply together. These are separate, okay? This is 2 factorial times 2 factorial. And it doesn't really come out very well with the 2's, but imagine if I had, let's just imagine over here, 3 factorial times 3 factorial. Oh, you might want to say to yourself, oh yeah, that's 9 factorial. But is it really? Really, this is 6 times 6, right? This is 3 times 2 times 1, I'm not going to put the ones, times 3 times 2 times 1, which is really 6 times 6, which is 36. Now 9 factorial would have been 9 times 8 times 7 times 6, and so on. Okay, so that's not the case. This is not okay. So something like this, I go straight to my calculator. I don't even try and mess around with it. Okay, so let's see here. So I'm going to do 9 factorial and I'm going to divide that, and now I'm going to use parentheses. I'm going to do 2 factorial times another 2 factorial. I get a total of 90,720.